First, thank you for coming, for attending this small topic. Actually, today we are talking funny stuff. So the topic is from Alibaba internal best practices. So the story is simple in itself. We will tell the story about in the past 2 years how Alibaba Group moved from in-house container program to the cloud-native architecture, which is a Kubernetes, and how we address the large-scale migration issues. First, I'll start with Alibaba's background. You may already know that Alibaba started to deploy the planet a long time ago. As early as 2011, we call it this phase a container phase. So there are no Docker technologies available at that time. So developers developed something based on TLC. And many companies, Baidu, they have a matrix like this to address a similar problem. So this is the container phase. And our layer. But because of the containers models are virtual, so in one pod there's only one container and several sessions in one volume. And after 2018, Li Xiang and other Kubernetes members joined the team. So we were promoting a Kubernetes system. So this is the starting point of Ali's cloud-native progress. In 2019, we started an experiment called cloud-native, and Ali is about to use Ali Cloud is to deploy Ali Cloud. So that is actually our slogan for a cloud native environment. And we removed the concept of a single container. Now we support multiple containers in one pod. And after all these reforms, Ali's cloud technology is based on Kubernetes. I'll show you a chart based on some of the mainstream open source projects. For example, Kubernetes, Helm, Operators Framework, Containerd, CSI. All these things are part of the framework. Even our monitoring system are quite pervasive and standard thing. We have a container to provide a very high isolation. And the cluster we are using is actually an OM tool, like our framework from ACK. We use Kubernetes to deploy ACK, and this model is quite a standard in the industry. I deploy a meta Kubernetes method, and then from there to deploy multiple clusters facing the users. And this Kubernetes model, we can use this chart to illustrate our team as infrastructure developer. We serve two clients. Ali Group, the second client, is the technical team under the Ali Cloud. So we are facing a wide portfolio of clients, including the PaaS, OM systems, Dev tools in Ali Group, as well as some of the existing and employed monitoring systems. They should all be docked to Kubernetes. And also, Alibaba has a lot of online businesses, Taobao, Tmall, etc. And some of Alibaba's AI businesses, offshore businesses, should all be docked with Kubernetes. So we have about 10 large clusters. So that means over 10,000 units and over 1 million containers. For some companies, they only maintain a few thousand small micro clusters, but we are moving towards another direction. In Ali, we have a complex structure. We cannot use one system for all, but we have some thinkings. Like our QB server, we will not modify it. We will use the upstream server because the maintenance of the server is complex. If you want to balance, it will be difficult for us to maintain the server by ourselves. And also, it provides a standard entry point. It's the very soul and idea of Kubernetes. So we don't want to, interfere in that regard. And as a big company, the scheduling policy must be very diversified, and the upstream cannot fully cater to the needs. We have also optimized the performances. At the very earliest, one Ali employee said when choosing the mall, he will only take 100 samples, even if there are 10,000 available. And he will use a sample to adjust the 100 units. And this is a standard practice by using some strategies to reduce the sampling quantity. And later on, we added this feature. It uses a horovoving to change the portfolio and the quantity, the content of the node is based on one idea. In the past, 10,000 sampling is required, but now not anymore. So this is about the scheduler. Scheduler is in-house developed. It can process batch as well as online businesses. So our mixed business is based on this scheduler. And in terms of controller manager, we use the upstream system, but above it, we have an in-house developed controller. In Ali, we highlight in-place upgrade. We don't want to, after upgrade, the container will go somewhere else, IP address and topology will change. This is not conducive and deadly for our business. And we're also doing a mixed, a multi-tenancy add-on. So it's a result of a complex computing. So every time if I update my business, it redistribute the resources, then this scheduler is facing a tremendous pressure indeed. So we want to ensure that to maintain a foreseeable and reasonable stability. And also, every step must be precisely controlled by our operator. I will talk about it later. We have separated as an independent project.
And for controller, first of all, it's based on its mechanism. However, we need to write one of the controller that is suitable to our usage, and also it needs to deal with some requirements on depth and also the other query as well. And in Alibaba, we have some projects. And we use the logic. It's based on its functions. And for this logic is a special instance here in Ali. And in this class, the logic class, we are going to. We do not use Doha because you can test the frequency of Doha because it's much slower. It has used a lot of the extra things to it, so it's meaningless to us. And before we use punch container, but now we have improved it. And as for the cloud, we use a very high ACK, the CSI, CNI, and to make it into cloud provider. And also, for some of the big products, it needs the elasticity. And also, sometimes it should be flexible because this is a physical pool. It's not easy to scale. It's fixed. So we need to able to borrow some resources from others. So we connected with the elastic resource pool, and we call it the ECI, and it's an elastic resource pool so that it can. It's a place where we can borrow some of the resources to fit in the scenarios. So it has built up a new system. Before we do not use it like that. And also we have a special bare metal instance just mentioned. And you can see there are a lot of tenants in our systems, and this is virtual cluster. We call it virtual cluster. And in these resource pools, the users are not going to use it. We have made some plugins here so that the Kubernetes are able to show and expose the APIs of all tenants you can consider. We have API servers to all of these, and it has the API objects. it's a virtual object, and this virtual power, the virtual things is a small, but there is no nodes because all of business will be located into the clusters. So all of them are sharing the same pools, and each of them will have an independent API. So this is the virtual cluster, and this is what we are working on. And in the future, it will be an open source. This is our current resource model now, and it's for some of the technologies here. I can introduce to it. Started from 2018, we are doing the container things. So, what is the subcontainer? I think the rich container, they call it the system container. It means that in this system container, apart from the competition of the business, they also have some others like the other support, like the SSHD and etc. And when you look at the rich container of Alibaba and what kind of resource we have, like SHD, log, monetary, cache, VIP, all kind of things has been put in it, including some of the boot scripts and etc. You don't even know who have put those things in it. And first of all, I want to set up a rich container, and the SSH will put inside, and then they're going to start their script. Because at that time they want to connect with the business side much easier. Why we want to eliminate the rich container? Because it has cultivated a bad mode for operations and maintenance. You can see the development will just randomly write those codes in these containers, and they do not have any kind of concepts like reading only, etc. They just write the road and the other place just write better and then finish. So we want to eliminate the rich container because we don't think the rich container has any problem if you are able to containerize your operations and the rich container is okay. But in our conditions now with this rich container, the operations of Alibaba's model has some problems. So starting from 2018, we decided to eliminate the rich container. Now we have a lot of improvement. All of our containers nowadays are actually lightweighted containers, so that we can make it into the ports with several ports. Because upstream we have done some standardized work on our users. For example, in the cloud native of Alibaba, one of the ports will include these containers. First of all, is its business container. It also will have some of the live upgrading sidecar. For example, I have an application, want to upgrade it, and then it's going to load a custom sidecar into it, and then you don't have to redo it again. Before, maybe you need to copy it to the rich container. Now you don't have to do that because we have the sidecar. We have make a sidecar. Sidecar just work on one thing. Now you want to upgrade. Okay, so sidecar the input of the sidecar is upgrade content. So it's going to copy this sidecar content to this because they can show the volume inside it, and also we can sure they can share this log as well. So in this port, we are able to enable the upgrading as well. Next, we also have the assistant engine and also help us to fix some small bugs as well. So it will include different kind of ports. And all of those rich containers procedures has become one of the input here inside the ports. But there were some problems here that are unable to solve, and that is monitoring. Monitoring is actually rely on reading the documents, the files like the secure and other values as well. We need to find other way to address these problems. Originally, it's a rich container, and it's working on the VM. If you want to convert it into the pod, you need to solve first what is the booting sequence. Then we need to use a concept called NIC container. And what else is a life cycle hook. Some of the containers may be earlier than others, so the latter booted will would need to set some of the prerequisite conditions. So the business should first define these conditions for pre-start and post-start of these different containers to decide which one should start first. I give you an example here. All the hubs should first define all lifecycle code so that it's able to run properly, because we are trying to evolve to the cloud native. This is a very good path for us, and we have utilized a lot of things in Kubernetes, like the post cycle, container life cycle, to control it. Of course, you also need to define the liveness codes and in what way that you can consider a container has been started or not. And after we have eliminated the rich container, then you will find that originally I utilized the Kubernetes, which will cause different impact. One is automation. Why we will find automation impacts here? Because in the rich container it utilized system D. You are not going to know the life cycle or the application life cycle's connections. They don't have any coupling or any relation between them. However, the life cycle is aligned with the app's life cycle. So you are going to identify the systems. Then the systems will be better able to run itself off. So the documents, then you are able to build up the volume very fastly. And everybody are able to focus on their own functions, like monitoring. You just need to focusing on monitoring work. And later we are going to have sidecar operators to input the sidecar inside the containers. You don't have to do it yourself, or we have a colleague to introduce it. You can automatically put the sidecar in it, including the upgrading and deleting, and it will utilize it as the automated way, in an automated way, and everybody will able to focus on their functions. So we are going to find a lot of benefits after eliminating the rich containers. And later we are able to utilize it to work on more things. And first is the resource utilization, and also it's something that some of the life cycles are similar to the containers life cycle. So we are going to have application management to manage its life cycle, and then we are able to put the data into the volume, the persistent volume. I don't have to find another place to write this. So in the future, it's going to upgrade based on the community. So when we first built up the 1.10, later we have set to release, and then upgraded to 1.12, and now we have achieved 1.14. So you can see we're not going to lag behind to release of the communities, because the Kubernetes is able to, for Kubernetes you can control the minimum upgrade and changes. And next is the cloud native app management. We have a whole set Kubernetes, and we can do some of the leasing. And first, we need to define different kind of management and also relationship, and also how to deal with the multiple clusters and interaction between them. So here is the application and operation of it. And first of all is the infra operations. Next is the application operations, and we need to communicate with different teams, and they need to follow the Kubernetes concept in its development process. And we also need to explore what kind of definition of it. And now we are using Helm to define the applications. However, some of the resources are not applicable. So, for example, how can we define the native resources on Helm? And this kind of resources are not able to define by the documents. It's not easy to define it. So we are still working on it and communicating in the community that whether we are able to build up the application definition that is facing the cloud. It's based on cloud. later we are going to address this problem, we hope, hopefully. And as for the management, we are still doing some pilot and experiments. We have our own thinking. First, we are utilizing the definition from help. So we need to build up a hub, an app hub. But the official app hub is not that big in China. And also there are different kinds of challenges like the GCR.io. And we need to do some localization based on this hub. And we have put it in the Ali Cloud and provide some free services. You can utilize this hub, and we can automatically synchronize with the official hub. And also you can utilize some of the VR there as well. Because the cloud native GitHub is also completely open, you can utilize it there as well. And as for Kubernetes, there are different types of tools, and it's mainly the yarn documents. And how can we allocate the documents, and also how can we configure those parameters? And we utilize the help to change some of the definitions and also parameters. And we have utilized Kubernetes native to work on some of the changes. And you need to use the standards to do the decoupling. And like Jenkins, the old Jenkins, you need to start it from the beginning to the end to put it into the KBS. In KBS, for example, I have an application and its documents in Git. And in the KBS, there are a lot of components. And they are able to automatically modify the utilization states of the applications. If it finds that I'm lack of resource and need to scale the instances number, then the operations is that they need to modify the replica, and they need to change the number of the replica to 10, and it's able to change upwards. And no matter where you have put your documents, write your documents, they need to write it there. If there is a black box between the AIC and CI, for example, I do not allow you to store the format, then my HAPA are not able to change the documents. I have the YAML documents, however, it's going to be modified by the developers. It also be able to modify the Kubernetes. If you need the Kubernetes to change it, you should have the open protocol that could be understood by the KBS so that it can operate this process. So I think the CI and OP are able to do this communication. However, study from the source, packed from the source code, and then build up different, to go through different process, and then put these documents into resources, and all those generated documents could be put into Git, because it has been put at the Git. So we are going to have GitHub. We don't think we need to go even further. So after we put it into the GitHub, we are going to manage this process.
Next, I'll talk about how our workloads is dealing our processing. Maybe you're already hungry, so I'll keep it short and quick. Speaking of Ali, the first thing come into mind is the November the 11th shopping day. Currently, we have nearly 1 million containers on the cloud, distributed in over 100 server rooms, with hundreds of thousands of applications. So this quantity of infrastructure moving to cloud, we are facing the stability and some other risk factors. And we're also assisting the PaaS platforms on the upstream to migrate to the cloud instead of PaaS remain unchanged. Otherwise, it cannot cater to our needs. So let me talk about the November 11th issue. You know that what our upper applications have done for November 11th, Tmall and Taobao, they will share this, disclose this information. About our infrastructure or big Kubernetes, what will it prepare for November the 11th? So on November the 11th, the traffic is like n times of daily average, even over 100 times. So we need far more resources than what we need on a daily basis. So before November the 11th, the first thing is to establish the station. So by scalable resources, first we should upscale the resources before November the 11th on one hand to improve the resource utilization rate, and second to stabilize November 11th. Suppose we were to upgrade our pod into 10,000 units. So should we rely on changing the quantity of a replica? This way, the risk, because the scheduler itself does not know what applications and their scalability. It can only check the status quo and whether it needs to be expanded or not. If we were to scale up to hundreds of thousands of pods, if we rely on this strategy, this individual scheduling strategy, the outcome can definitely not cater to our needs. Some of the resource overlap, and some of the rules will not be met. So when establishing the nodes, we use an offline scheduler to understand the status quo of the resources, and then matchmake with the hundreds of thousands of pods to enable centralized distribution. And after that, through batch placement, we based on the feedbacks, we use the batch placement to enforce the resource distribution. Internally, we use the two CRD to deliver the function. One is called a batch allocation plan, the other is called a batch adoption. So batch allocation plan, by its name, it creates buffer pods with candidate nodes. That is to say, in this flexible resource pool, if we were to create hundreds of thousands of pods, we cannot guarantee that the first distribution is in line with our expectation. So the batch allocation plan allows the creation of a buffer pods until we distribute the resources at a reasonable level. When it meets our expectation, we will reinforce that action. So in this way, the overall resource distribution meets our expectation. And if you're familiar with the Kubernetes, the default release strategy is to recreate pod. The problem is after our efforts, maybe the hundreds of thousands of pods, it finally met our expectation. And when one application released it, then all other pods will migrate away. So it will not meet our expectation. Now, before November 11th, Ali will go through several times of the whole circuit through prediction. So during the testing phase, even if it passed the verification, but upon release, we cannot guarantee the actual outcome can meet our expectation. So this is the release strategy from the meta, there's some release strategies provided, but no matter what strategy we use, part migration is part of it. So part migration breaks our expectation to the stability of the part. So we developed this. It's called an in-place update. So when releasing, we can upgrade the container on the very same spot instead of recreating a part. So for upstream users, you don't need to, you don't care about this part, but I only give a brief introduction of it. So within the advanced stateful set, if we set up the partition to be 1, then under this condition, the advanced controller will only upgrade the container, the corresponding container that you intend to modify. And after that, Kubernetes will identify the container's hash value has changed. Then it will use new mirror image to recreate the file. In the process, the Sidecar containers in the pod is in operation. That means it's unaffected. On the other way around, if we need to upgrade the Sidecar container, it will not affect the application container. And this is what the default model cannot support. In a template, if there are multiple containers in the pod, if your components and container is to upgrade the version or the mirror image, because it uses a pod recreation strategy, it will cause the deletion of the old part and to create a new part. And this does not meet our expectation. We want the upgrade of the component not affecting the business going online, because it affects the stability. For comparison, to put it simply, the default model and our rolling update, in-place update can better cater to our needs. For example, to ensure the certainty of the system, we know that Docker and containers of mirror image, if it's upgraded on the very same spot, some of the layers can continue to be used. So it improves efficiency, even if for the buffer resource demand. And that's another issue. Kubernetes, the default strategy for recreating it, is difficult for Ali to execute. For one, it's because of the uncertainty and also Ali's sheer volume. Every day our online app release reaches 6,000, even 10,000 times. And each app, just like Zhang has said, there are over 10,000 parts under each. If we were to recreate it in order to upgrade it, then there's a huge pressure upon the scheduler. So every release, it will distribute tens of thousands of parts. And for the supply chain, for the service registration, it will cause a tremendous pressure. So through in-place update, we can recreate the part lightweightedly without modifying, without rescheduling. And now I'd like to say a few things about another CAD we do. It's called Sidecar. Let's first take a look at the problems of the traditional model. And beta, you define a step set, or whether the template includes your expected containers, like your business container, your sidecar container, your OM components, your agents, and other authorized components. And these components were all defined in this block. For some small-scale operation, it's fine. But for large-scale operation, the first thing we encounter is for the operators, the managers. You know that Ali have over 100,000 applications, and the operator of the application, they don't know that which sidecar set is required, and they don't want to pay attention to such details related to OM. And the operators, business operator, they only care about the stability of the system, the upgrade of the system. They don't care the sidecar components. The second issue being that when we define the sidecar in a working environment, the question is how to upgrade it. We know that Ali's workload, hundreds of thousands of units. So when the component main operator is expected to manage hundreds of thousands of blocks, it is painstaking. Secondly, because the application, the definition, they are within the same block. So when the upgrade of the container and components are conflicting with each other, it will also affect the container stability. For example, when we're upgrading the application and the maintainer of the components identify the same problem, and he's modifying the sidecar version of the stateful, then these two actions will conflict with each other. So to cater to this problem, we developed a lightweight development tool. It does a very simple thing. It separates the container and other components upgrade. So with the sidecar, the app maintenance, it only needs to define and maintain the mirror image of the application. So application developers does not have to care about the sidecars. All the sidecar components are all defined within the sidecar sets. With we have dedicated sidecar maintenance teams to say to the maintenance. And soon as the part is scaling up, every time the part is scaling up, the sidecar set will have an admission will put to intercept this action. And it will compare whether the part level is in line with the selection criteria. If yes, then it will inject into the corresponding part, the sidecar as needed.
For example, on Ali, we have nearly 1 billion pods. And how can we manage those pods? It's very simple. We just need to define one sidecar, and we don't have to input the definition of the sidecars on all those pods online. And these sidecars are going to inject the containers we need in all the pods online. So in this way, it can successfully combine the sidecar combined with separate from the business. First, we have utilized a developer. Developer do not have to pay attention to the sidecar container and the management of it. And also the manager of the sidecar can easily use this sidecar set to manage all those sidecar containers online to work on the upgrading so that it will not affect the original business running. So here is a map that I've introduced. Once we have defined the sidecars CRD and the operator's behaviors like that, it's going to inject the sidecars into all those the ports that fit the selected conditions. And the upgrades and delete of the sidecars will just fit in its mechanisms of working of these sidecars. For example, when the operator wants to manage it, it just needs to match with the mirror of the sidecar. And then it's going to utilize its upgrade strategy to upgrade all the sidecar versions. And they don't have to. The managers do not have to utilize the other resources to do that. So it would be a much easier way to couple. And we know that the Sidecar Set and Istio inject have some similarity, but there was some difference. Istio, it's based on the selected conditions and injected into the containers and have a specific location of injecting. And sidecars provide a richer set of functions. For example, there is a designed maps for the logs, and these components need to read some data from it. So it needs the sidecars to share with the containers on data. So at this time, the sidecar has become a data volume mounting tools that are able to share the data volumes with the container. And also, we are able to, in this way, we are able to gradually upgrade the online sidecars containers without awareness from the business people, and also the managers and the users of these containers are actually do not have to aware these upgrades. And we also have the local upgrade functions. Maybe you will not feel about it, these two functions. However, we have provided to an open source project that is OpenKruise, and you can visit this. And this is the output, and all of the output functions has been proved internally in Alibaba, and also it's based on some of the demand scenarios internally, and we are not going to 100% output deliver all those functions. We're going to gradually push some of the generic functions into the community so that we can build up these functions together. I want to introduce the OpenKruise functions. And the Cruise is the core function of the OpenKruise project. And also, it has provided some of the basic and daily functions. One is broadcast job, and one is the Sidecar Set. Maybe you haven't heard about the broadcast job. Before, we also have some of those jobs. It's similar to the combination between the two original functions. So once the job runs, then it will finish. It's going to dispatch different jobs to different places across different nodes in the clusters. Okay, I'm going to generally talk about the advanced stateful set. We provide two functions. One is max available, and for example, and for the default stateful set, if the policy has choose parallel. However, when it's releasing, it's going to release ports one by one if we have 500 ports. Even though you used a partition to set it into 10 batches, but these 50 ports in each batch will still be released one by one. However, the max available are able to do the parallel release of these ports together. For example, all the 10 batches, in each batches, the 50 ports will be released in a parallel way, so it will be 50 times accelerated during this process on updating. This is in place update. Maybe you have been familiar with it because it's next is Sidecar Set. We're going to inject the sidecar into the container that has the ports that has been selected based on some conditions. And by combining with some containers, they are going to be run on each of the nodes across the clusters. And we're going to stop here for today's talks. And you can contact me on WeChat. And also welcome all of you.